Good morning everyone. So this is my next lecture based on MOSFET. So in the last lecture we have seen about different type of MOS capacitor. So where we can find useful applications in various basic electronic circuits. We can use MOSFET in terms of different type of capacitors. So here we are going to deal with what is MOSFET. So MOSFETs have different characteristics similar to JFET. We have deal with BJTs, that is bipolar junction transistors. So in MOSFET it is a unipolar device as compared to the BJT, which is a bipolar device. So MOSFET have characteristics similar to JFET and have additional characteristic that makes them very useful. So what there are two types of basically MOSFET: metal oxide semiconductor field effect transistors. So it has depletion mode MOSFET, which is also called as D MOSFET, which operates in the depletion mode in the same way as the JFET will work, as we have discussed already that the JFET will work when VGS is less than or equivalent to 0. So the gate and the source voltage should be less than or equivalent to 0. It also operates in the enhancement mode like E MOSFET. So where we are having to create a channel in the case of the enhancement mode. In the depletion mode, the channel is already there. We have to deplete the channel with the help of the gate and the source voltage. So in the enhancement mode MOSFET, we have only it will operate only in the enhancement mode, and in that case the drain source current must be 0 until whenever you increase the voltage, the gate source voltage must be greater than VT, which is your threshold voltage or the knee voltage. So whenever the VGS, the voltage, gate source voltage is greater than threshold voltage, until that point, before that point, the drain current will be 0, and after that the drain current will keeps on rising. So basically the summary is that there are two types of MOSFET: depletion type of MOSFET and the enhancement type of MOSFET. The depletion type of MOSFET will work in the case when VGS is less than equivalent to 0, and in the enhancement type it works only when VGS is greater than 0. The next important point is this, that is, until VGS is greater than VT, up to that point IDSS is equivalent to 0. After that the drain current will keeps on increasing. So then there will be in the characteristic we will see that it will be in saturation region. The MOSFET will work in saturation region. So if we compare both BJT and MOSFET, there are some parameters on the basis of we are comparing these two different devices. The first parameter is the output current. So in the case of the MOSFET, it is controlled by the input gate voltage. Whenever we apply the input gate voltage, that is the VGS between the gate and the source, only then there will be a rise in the drain current. The BJT bipolar junction transistor is controlled by the input base current. So whenever we apply the base current, only then there will be a change in the collector current. In terms of cost, if we see, then MOSFET is more expensive as compared to BJT, and BJT has lower cost. In terms of ESD, that is the damage, electrostatic discharge damage. So in terms of that, we can see that MOSFET has easily damaged by ESD, electrostatic discharge. Even in the case of the BJT, we don't have these type of problems in there. So next we have switching speed and frequency response. So we can see from the table that it is faster than bipolar. Better frequency response is shown in the case of the MOSFET, while BJT have slower than MOSFET and it is inferior frequency response. If we talk about thermal runaway, when MOSFETs heats up, the current flowing through them decreases. They are less likely to be destroyed by overheating normally. So that's why we are using nowadays MOSFETs in various electronic devices. When bipolar transistor heats up, the gain increases, and so the current through them increases too. So this in turn causes increase in the heating, yet more gain and current. So this can cause catastrophic failure called thermal runaway also. So next is the gain, last is the gain. So this gain, in terms of if we compare the gain between the MOSFET and the BJT, we have very high current gain which is nearly constant for varying drain currents. But in the case of the BJTs, we have lower current gain and it is not constant here. So we can find out if you compare both MOSFET and BJT, you will find a MOSFET is more useful in terms of it has less noises, it has less damaged by electrostatic discharge, it has better frequency response, it has no overheating problem and all. While in the BJT, if obviously in cost point of view, if we compare both these things, so BJT is obviously a better option. So these are some parameters on which we have compared BJT and MOSFET. So next, the MOSFET is basically categorized into two parts, that is depletion and the enhancement. So in the depletion type of MOSFET, what is depletion mode? So firstly, we have to see what is depletion mode. With a negative gate voltage, if we apply negative gate voltage, the negative charges on the gate repel conduction electrons from the channel. So in the depletion type of MOSFET, we have a negative gate voltage and there will be a P type of substrate, and it has source and the drain, which is obviously negative type of, that is N type of source and the drain, and they will repel the electrons forming in the channel between the source and the drain. So leaving positive ions in their place, thereby the channel is depleted of some of its electron, thus decreasing the channel conductivity. So the greater the negative voltage if we are applying on the gate, the greater the depletion of the N channel electrons in between the source and the drain. So at sufficiently negative gate to source voltage, we have VGS off, the channel is totally depleted and the drain current in that case becomes 0. On the other hand, in the enhancement mode, what we have to do in the enhancement mode, we have to apply a positive gate voltage. So what if we apply positive gate voltage, more number of electrons attracted towards positive gate voltage and they will create a channel there. So it will increase the conductivity of the MOSFET. So here there are two type of MOSFETs which is shown in the figure, the N channel and the P channel. So in the N channel, we have, obviously the channel is N type, the substrate should be of P type. Similarly, the P channel, the channel is of P type and the substrate should be of N type. So accordingly, if we apply a positive VGS or a negative VGS, the MOSFET will work in the depletion or in the enhancement mode. So here there is a figure showing the same thing, that is the P type of substrate, the N type of source and the drain, and in between there is a N channel. So we have source here which is connected to the first N channel, which is also, we have N doped, so it is represented as N plus. Similarly, this drain is also represented as N plus, and this particular portion is your channel. The substrate is of P type, so if we apply a positive voltage here in the gate, so what will happen, the electrons will get attracted towards the positive voltage and they will form a channel between the source and the drain, and it will create your enhancement type of MOSFET. So for enhancement type of MOSFET, what we are doing, we are applying a positive voltage at the gate. First point is this. Second point, if we apply a negative voltage at the gate, what will happen? The electrons will get repelled from the negative voltage and there will be a depletion type of MOSFET creation with this case. So for depletion type of MOSFET creation, what will happen? We have to apply a negative voltage. For this case, whenever there is a P type of substrate and N type of source and the drain, I am taking off this case particularly. If you want, you can take a N type of substrate and a P type of doped source and the drain. So in this case, what will create it? The electrons will get repelled. And there will be a depletion type of MOSFET creation in this structure. So for depletion type of mode MOSFET, what we will have to do, we have to apply a negative voltage at the gate. This layer is basically silicon dioxide layer and the above layer is your metal layer, metal contacts. So on the construction of N channel, if we see the construction of the N channel, two highly doped N regions are diffused into a lightly doped P type substrate that have an additional terminal connection called SS. The two highly doped N regions represent source and the drain. Basically, it is source and the drain connected by an N channel. The N channel is formed by diffusion between the source and the drain. The type of the impurity for the channel is the same as for the source and the drain. Metal is deposited through the holes to provide drain and the source terminals. So metal is deposited, a kind of aluminum or kind of metal is deposited on the source and the drain, and on the surface area between the drain and the source, also on the area between the drain and the source, the metal plate is deposited. This layer constitutes the gate. The N channel is connected to the gate. Basically, a thin insulating layer of SiO2 is below the metal layer. So the thin layer of SiO2 dielectric is grown over the entire surface, and the holes are cut through the SiO2. So silicon dioxide layer to make contact with the N blocks. So what we have written here, that is the construction, on the point of the construction point of view, that what will be the layers, the P type of layers. In between the P type of layers, there will be N type of a channel creation, or because of the N type of the substrate. So there will be a creation of the channel here, and a deposition of the metal layer, below which there will be a silicon dioxide layer. So if we see the operation of the N channel depletion MOSFET, a D MOSFET may be biased to operate in two modes. The first one is the depletion mode, and the second one is the enhancement mode. Whenever VGS is equivalent to 0, drain is made positive with respect to source current, and in the form of the electrons can flow between source and drains. So even with 0 voltage applied to the gate, the MOSFET is said to be operating in the enhancement mode. So in this mode of the operation, obviously if we are applying a negative voltage and you have to create the channel, so what we have to, if we want to create a N type of channel, we have to apply a positive voltage. So whenever you apply positive voltage, the electrons get attracted towards the channel and between the gate and the source, and they will create a channel. So when VGS is equivalent to negative with respect to substrate, what will happen? The gate repels some of the, so for the depletion type, what we have to do? We have to apply the negative voltage. So when VGS is equivalent to negative, with respect to substrate, the gate repels some of the negative charge carriers out of the N channel, and it attracts the holes from the P type of substrate. So what will this initiate? Recombination of holes and electrons, and this creates a depletion region in the channel, and therefore reduces the number of free electrons, that is more negative in between the gate and in between the source and the drain, or in below the gate. So the less the drain current, so there will be less drain current in this type of mode. So in this mode of operation, the device is referred to as depletion mode MOSFET, because the channel has been depleted out of the MOSFET. So here too much negative gate voltage can pinch off the channel. So whenever you are applying the voltage VGS, and whenever you are creating the too much more negative voltage towards the more negative voltage VGS value, so that will create a pinch off of the channel. So the more the positive the gate is made, more number of electrons from the P substrate due to reverse leakage current and collision between accelerating particles, and more drain current flows. So whenever you apply the positive voltage, there will be attraction of the electrons towards the gate, and there will be a flow of drain current starts. So if we see the characteristic, so we have the characteristic which is similar to the BJT. We have already discussed in the last lecture also. Here we have mentioned some values on the characteristic. So we have applied VDS, that is the drain source voltage, and we have a drain characteristic, that is the output drain. Here is in the y-axis. So we have applied VGS. Whenever VGS is equivalent to 0 volt, then plus 1 volt, then minus 1, minus 2, minus 3, minus 4, minus 5. So at negative voltages, what will happen? At negative voltages, we have pinch of the channel, that is basically depletion mode of MOSFET. So below VGS is equivalent to 0 volt, it works as a depletion type. Above 0 volt, that is plus 1 volt, plus 2 volt, it works as an enhancement type. So for this values, it works as depletion type, and for these values, it works as enhancement type according to the applied voltage on the gate. So whenever you apply negative voltage to the gate, it works as depletion type, because electrons will get repelled, and positive holes will get attracted towards the channel. In the enhancement type, we have to provide a positive voltage, so that more number of negative electrons will get attracted towards the channel. So here there is a current. So below in the depletion type of MOSFET, so there is lesser current, so it is very less here. So this is less, and in the case of the enhancement type it is more. So we have more current in the case of the enhancement type as compared to the depletion type. So if we see about drain characteristic for VGS exceeding 0, the device operates in enhancement mode. So obviously I have told you that whenever you increase from VGS is equivalent to 0 to +1, +2 and +3, in the positive side it works as an enhancement mode. These drain curves again display an ohmic region and it a constant current source region and a cutoff region. So we know that there are 3 types of region, that is the ohmic region, active region, the cutoff region and the saturation region. In the case of the BJT, we have firstly the saturation region, then the ohmic region, and below the ohmic region there is a cutoff region. But in the case of the MOSFET, it is somewhat different. So at the start it is having a ohmic region, and then below ohmic region it is cutoff region, and after the ohmic region there is saturation region whenever the drain current becomes stable, that is IDS becomes stable. So for a specified drain source voltage, that is IDS, VGS off is the gate source voltage at which drain current reduces to a certain specified negligibly small value. So at wherever the drain current is very small, very negligible, that region is basically your cutoff region. So for VGS, between VGS off, that is the negative value, and 0, the device operates in depletion mode. So below VGS is equivalent to 0 volt to below the VGS is in the negative direction, we have the depletion type of MOSFET, and above VGS is equivalent to 0 and including VGS is equivalent to 0, the device operates in a enhancement mode. So this curve basically shows the nature of the MOSFETs in the enhancement mode. So we have at VGS is equivalent to 0 volt, it works as a enhancement mode. Below VGS is equivalent to 0 mode, that is -1, -2, -3, -4, -5, -6, it works as an depletion mode. So this is particularly depletion mode, and this region is your enhancement mode. That's why in the curve we have shown this part, this is the left part is your depletion type MOSFET and the right part is your enhancement type MOSFET. The current obviously at VGS is equivalent to 0, the current is very high, which is equivalent to IDSS, and as you increase VGS in a positive direction, the current keeps on increasing. But in the negative direction, the current is very less. So at -2, if you see, the current is IDSS by 2, at -3, the current is IDSS by 4. So as you decrease the VGS value from 0.3 to Vp by 2 and so on, the current, that is the drain current, becomes less. So the transfer characteristics are similar to the JFET. In depletion mode, we have VGS is equivalent to 0 volt and ID is equivalent to IDSS. When VGS is less than 0 volt, then obviously ID is less than IDSS. When VGS is greater than 0 volt, then ID is greater than IDS. So these 3 points are very important to know wherever the MOSFET is working, in which region the MOSFET is working, and at in the form of which device, like an enhancement mode or a depletion type mode. So enhancement mode operation, in this mode the transistor operates with VGS is greater than 0 volt and IDSS increases with a Shockley equation, which is your diode equation. So this is diode equation or Shockley equation. According to that, the VGS or the IDS, because you are applying VGS is greater than 0 volt and obviously the ID is increased or ID is greater than IDSS. So this is the expression through which we can find out what will be the value of the ID. So here ID is equivalent to IDSS 1 minus VGS upon Vp, which is where Vp is your pinch off voltage. Pinch off voltage. So VGS upon Vp to the power to the square. So by this formula we can easily calculate the value of the ID, that is the drain current, or in terms of DSSS, obviously we have to see what is the value of the VGS, is it greater than 0 or less than 0, and we have to see with the graph we can easily calculate the value of the pinch off voltage. So whatever the pinch off voltage we have or in the numerical problems we just put it down and we can easily calculate the value of the ID. So in the next we have p channel depletion MOSFET. So in the same way as we have discussed about N-channel depletion MOSFET or the enhancement MOSFET, we have P channel of depletion MOSFET. So here the source and the drain has the P plus type of doping. So we have P plus doping in the source and we have P plus doping in the drain. So positive doping in the source and the positive doping in the drain. So we have VGS greater than threshold voltage whenever the VGS is greater than equivalent to VT. Only in that case the MOSFET will works in the depletion type of mode MOSFET. So you are applying the negative voltage to the gate and there is N type of substrate in the bottom. So obviously the N type of substrate will make the holes to be attracted towards the gate and it will create a P channel depletion type of MOSFET. So initially in the P channel depletion type of MOSFET, what will happen, there will be a formation of channel initially, but as you apply the gate voltage in the negative form, then there will be a P channel depletion type of MOSFET creation, because as you apply the negative voltage, the holes will get attracted towards here and it will create a P channel depletion type of MOSFET. So we can see from the characteristic, the first diagram, which is A diagram, the P channel depletion type of MOSFET is similar to N channel, except that the voltage polarities and current directions are getting reversed. So here we have P type of source and the drain, and we have P channel creation, obviously N type of substrate. So this is N type of substrate, P type of source and the drain. So the drain current will increase in the same way, that is VGS is greater than equivalent to VT. So only in that case the drain current will increase, but here we have to apply a positive voltage at the gate. So when you apply positive voltage, electrons get attracted towards it and electrons get attracted towards here, and there will be a formation of the negative ions in the P type of layer. So obviously the P channel will get depleted because the formation of the electrons will get accumulated at the in between the source and the drain. So in the graph we can see that VGS is applied and ID is the drain current which we have to calculate. So as you increase the voltage, that is the pinch off voltage here at the 6. So at 0 VGS is equivalent to 0 volt, the current is IDSS. At the negative the current is very less, and as you increase the voltage VGS, so there will be a decrease in the current as in the reverse case, as in the case of the P type. So here the everything is to be reversed. In the case of the P type, this is increasing type of curve, and obviously in the negative direction it is decreasing. Here in the negative direction it is increasing, and in the positive direction it gets decreased. So in the C part we have the output characteristic. So we can see that in between VDS and ID. So as you increase the gate and source voltage here, as you apply plus 6, plus 5, plus 4. So as you increase 0, plus 1, plus 2, plus 3, plus 4, plus 5, there will be a decrease in the current. As you apply minus 1 volt, it will increase. So it is almost similar to P type of MOSFET, depletion type of MOSFET, but it is just reversed from it. Wherever the current increases in the P type of depletion type of MOSFET, here N type of depletion type of MOSFET, here in the P type of depletion MOSFET, the current will keeps on decreasing. So next we have enhancement MOSFET. So the schematic symbol for the N channel and P channel E MOSFET are shown in figure below. So the N channel have the source and the gate and the drain, and the P channel have the same thing. The current directions are different. The current directions are in the inward and the outward direction. For the N channel it is in inward direction, for the P channel it is obviously outward direction. The conventional enhancement MOSFET have a long thin lateral channel as shown in structural view in figure below. So we have P type of substrate here, N type of source and the drain, and the gate is here. So we are applying silicon dioxide layer is here, the gate is of aluminium. So we are applying a negative charge to the gate. So whenever you apply a negative charge of the gate, obviously there will be electrons get attracted to the holes positive charge at the gate. So whenever we apply positive charge at the gate, the electrons get attracted towards the N channel and they will form a channel here, which is called as enhancement. So for creating enhancement type of channel in the P type of substrate, we have to apply a positive voltage. So it will create your N channel, which is your enhancement type. So by this you can see the difference between the enhancement and the depletion type of MOSFET. In the depletion type, already the channel is there, we have to deplete the channel. So in the P type of depletion type of MOSFET, we have P type of channel already created, we have to apply a negative voltage there, and there will be formation positive voltage, and there will be formation of more number of electrons in between the source and the drain, and the channel will get depleted. On the other hand, in the enhancement type, we have to enhance the channel. So that's why we are applying positive voltage at the gate, and more number of electrons get attracted towards the gate, and they will form the N type of channel in the same way as in the depletion type. It is enhanced MOSFET. So thank you so much. In these two lectures, we have discussed about MOSFETs and MOSFETs characteristics. So we have to see where the MOSFETs are applicable, where we can use MOSFET, where we can use BJT. Both are equally important devices. Wherever the cost is concerned, we can use BJTs. Wherever the damage and all heating problems is concerned, we can use MOSFETs. On the other hand, MOSFET has wide range. It can be used in a wide range of the voltage as you apply gate source voltage between the gate and the source, and according to that the drain current will keeps on increasing. So both have the threshold voltage, both have the pinch off voltage or the knee voltage, but we have to see wherever you can use MOSFET and the BJT separately. So thank you so much. In the next lecture, we are going to see about more details of the MOSFET and then about lasers and LEDs, which are useful semiconductor devices. Thank you.